In this video, you will use the educational version of PyMOL for the upcoming lab. If you have not downloaded the software, stop the video and download it before proceeding. It is to your advantage to follow along what you'll see in the video to make sure the software is working properly before coming to lab. Don't forget to download the file 1mbn_pymol.pse to follow along. If you are done downloading the file, let's begin. The directions in this video should work for both MacBook and PC. The program is already open on my computer. We'll begin by opening a file. You should have downloaded the file called 1mbn_pymol.pse. You're going to open the file by going to the File tab, then Open. The file is saved on my desktop. Double-click on the file and it should open. The first things you'll learn are some mouse controls that work for both MacBooks and PCs. Some people might have an external mouse, which makes it easier to work with this software, but it also works if you just have a mouse pad. The mouse control commands are very similar for both, but if there are any differences between them, I will point them out. We'll start with rotation. If you want to make the protein rotate, all you have to do is left-click and drag, and this rotates the protein in the direction you drag the mouse. If you want the protein to rotate along the x-axis, drag the mouse up and down. If you want the protein to rotate along the y-axis, drag the mouse left or right. Next is X and Y translation. To translate the protein on the X or Y plane for both the mouse and the mouse pad, press the Option key on your Mac or Alt for PC. Left-click and drag vertically if you want to move the protein along the y-axis and horizontally to move it along the x-axis. To zoom in and out, the mouse pad and mouse work differently. If you have a mouse pad, you have to right-click and press Command for a Mac or Control for a PC, and then drag to zoom in and out. If you have an external mouse, you can just right-click and drag to zoom in and out. All these mouse control commands will become handy during your lab. You'll also need to be able to locate, select, and identify the amino acids on the sequence of the protein. To make a selection, you can either just click and release the individual amino acid on the viewer screen, or, more conveniently, you can click on the S box at the very bottom right of the viewer screen. This will give your sequence across the top of the viewer screen and allow you to select residues by clicking on them. This becomes useful when you want to know the position of a specific residue that you might need. Another neat feature of PyMOL is that it allows you to measure distances between amino acid residues. On this example, we'll look at the distances between some atoms in aspartic acid 4,4, D44, and lysine 4,7, K47. To start measuring, go to the Wizard tab, scroll down to Measurements. On the right bottom corner of the viewer window, a list of commands will show up, but you do not need to click on any of these to start measuring. All you have to do is click where you want your measurement to start and end. Let's say you want to measure the distance between the oxygen of the side chain from D44 closest to the amino group of K47. This is what you have to do. You'll see that the distance will be about 2.7 angstroms. You could also measure the distance between the furthest oxygen from the side chain of D44 to the amino group of the side chain of K47. Using the mouse control commands you learned earlier, you can zoom in to have a clearer view of the distance. I'll zoom out again to do one more measurement. And this one will go from the oxygen in the carbonyl group to the main chain from D44 to the amino group in the main chain of K47. As you can see, making measurements is a very simple task. This is helpful when making predictions about the interaction among amino acid residues. There are a set of commands at the right bottom corner of the viewer's window. If you want to save your measurements, you can click Done. If you weren't satisfied with a measurement, you have the option of easily deleting them. In this case, I'll just save the measurements. And as you'll see, there is a list of measurements that will show up on the name panel of the viewer's window. For the lab, you'll also need to go over a series of scenes that have been created using PyMOL. And to go over these scenes, you'll have to go to the Scene tab, scroll down to the Recall tab. If any of these have a check mark, that means there is a scene saved under that code. We'll first look at F1. 2 amino acid residues are highlighted as stick figures in this scene, H119 and D122. Then we go to F2. In this scene, you'll see a more zoomed in version of the previous one. For the most part, that's how it will be for your lab. You'll be given 2 scenes, one that is zoomed in and another one is zoomed out version of the previous one. You're free to use whichever you feel is easier for you to manipulate and see. One last thing I want to point out is that there are different styles that can be used to show the protein. For this, we will go to scene F3. For the lab, you'll see something similar to this, where you'll see the cartoon version of the whole protein. In this case, you will see the alpha helices as cartoons, and the main chain of the protein will be shown in the line form. The line form is the thin wire shown underneath the alpha helices. Finally, if there are some residues that we want to highlight, they'll be in the stick figure form, and will include a label with a 3-letter amino acid abbreviation and their location in the primary structure of the protein. There are many more things that you can do with PyMOL, but for the purpose of this lab, these simple skills are enough. I hope you find this helpful.